The moon's surface is covered with a vast number of craters, which are one of its most prominent features. These craters are the result of impacts from meteorites, asteroids, and comets that have collided with the moon over billions of years. The lack of an atmosphere, geological activity, and weathering processes on the moon means that these craters remain largely unchanged over time, preserving a record of the solar system's history. Let's delve into the details of why the moon has craters. Early solar system bombardment. The solar system's formation about 4.6 billion years ago was a chaotic period marked by intense bombardment by leftover planetesimals, small, rocky bodies that eventually coalesced to form planets. The moon, being an early member of the solar system, was subjected to this heavy bombardment phase, known as the Late Heavy Bombardment, LHB, which occurred around 4.1 to 3.8 billion years ago. During this time, a large number of asteroids and comets collided with the moon, creating many of its largest and oldest craters. Formation of basins. Some of the largest impacts during the LHB created massive impact basins, such as the Imbrium, Serenitatis, and South Pole Aitken basins. These basins are several hundred kilometers wide and are some of the most significant features on the lunar surface. The material ejected from these impacts spread across the moon, creating secondary craters and further shaping the lunar landscape. Meteoroid impacts. The primary reason for the moon's craters is the impact of meteoroids, small rocky or metallic bodies from space. When a meteoroid collides with the moon at high speed, it releases a tremendous amount of energy, resulting in an explosion that creates a crater. The size of the crater is usually much larger than the meteoroid itself due to the explosive force of the impact. Asteroids and comets. Larger craters are often caused by impacts from asteroids and comets. Asteroids are rocky bodies, while comets are icy bodies with some rocky material. These objects, when they collide with the moon, create much larger craters, sometimes hundreds of kilometers across. Famous craters like Tycho and Copernicus are the result of such massive impacts. Simple craters. These are small, bowl-shaped craters with smooth walls. They are typically less than 15 to 20 kilometers in diameter and have a simple, rounded appearance. Complex craters. Larger craters often have central peaks, terraced walls, and flat floors. These features form due to the rebound of the surface after the impact, creating more intricate structures. Basins. The largest craters on the moon, called basins, can be hundreds of kilometers across. These massive impacts often lead to the formation of concentric rings around the crater. Dating the surface. By studying the number and distribution of craters, scientists can estimate the age of different regions on the moon's surface. Areas with more craters are typically older, while younger surfaces have fewer craters. Understanding the solar system. The moon's craters provide insights into the history of the solar system, including the frequency and size of impacts over time. This information helps scientists understand the processes that have shaped not only the moon but also other planetary bodies. Simple versus complex craters. The size of a crater significantly influences its structure. Simple craters, usually less than 20 kilometers in diameter, are bowl-shaped with smooth walls and a small central depression. Complex craters, which are larger, display more intricate features like central peaks, terraced walls, and flat floors. The central peaks form due to the rebound of the lunar surface following the impact, similar to a drop of water rebounding in slow motion. Multi-ring basins. The largest impacts on the moon create multi-ring basins, which are characterized by concentric rings of mountains surrounding the central impact site. These rings are formed due to the shock waves from the impact, which create a ripple effect on the lunar surface. The Oriental Basin is one of the best preserved examples of a multi-ring basin on the moon. Surface erosion and weathering. While the moon lacks an atmosphere and liquid water, its surface is covered by a layer of fine dust and broken rock called regolith. This regolith is created by the constant bombardment of micrometeorites, which break down the surface rock over time. However, this process is extremely slow compared to Earth, where water, wind, and biological activity rapidly erode surface features. The regolith helps to preserve impact craters by cushioning subsequent impacts and reducing erosion rates. Impact gardening, the process of continuous micrometeorite impacts, which churn and mix the upper layers of the regolith, is known as impact gardening. This process redistributes the regolith, but it also means that the surface layers are constantly being reworked, helping to bury and preserve older craters. Global distribution. Craters are distributed unevenly across the Moon's surface. The near side of the Moon, which faces Earth, has fewer craters compared to the far side. This is because the near side experienced more volcanic activity in its past, which resurfaced and covered older craters with lava flows, creating the dark plains known as Maria. The far side, which is more heavily cratered, represents a more ancient and less disturbed surface. Earth's atmosphere and geological activity. Earth also experiences impacts from meteorites, but its atmosphere burns up many of them before they can reach the surface. Those that do impact the Earth are often eroded or buried by geological processes such as plate tectonics, volcanism, and erosion. As a result, Earth has far fewer visible impact craters compared to the Moon, despite being hit by similar numbers of meteorites. Mars and Mercury. Comparing the Moon's craters with those on Mars and Mercury provides further insights. Mars has craters similar to the Moon, but they are often modified by wind, water, and volcanic activity, leading to more varied and complex crater landscapes. Mercury, like the Moon, lacks an atmosphere and has many craters, but its proximity to the Sun means it has been subjected to intense solar radiation, which has caused surface features to degrade over time. The Moon's craters are a window into the past, preserving a record of the solar system's history that is unparalleled on Earth. From their formation during the chaotic early days of the solar system to their preservation on a geologically inactive and atmosphereless world, lunar craters tell the story of impacts that have shaped not only the Moon but also our understanding of planetary processes. As we continue to explore the Moon, these craters will remain central to unraveling the mysteries of our celestial neighbor and the broader cosmos.